Hello, I'm Amin Karbasi, your host for Behind the Scene Chats. Today we are so excited to have Andrew here with us. He's one of the workshop chairs of this year ICML. And the reason that we are having behind the scene chats is that ICML and the ML community has grown dramatically in the last couple of years. So what we would like to do is to know how the decisions are being made, and so that we can better communicate to the audience here at ICML and to the ML community at large. Yesterday we had Catherine, one of the program chairs. So today we are very excited to have another very interesting person, Andrew, and so we are going to have a chat about the ICML in general and the workshop in particular. Hello, how are you
Hello.
doing?
Great, how are you?
Very good, very good. So, how was your flight?
It was easy. I had a direct flight from New York, and one of the benefits to living in New York is you can often take direct flights. I'm really loving Vienna as well as a venue. I was here also for iClear, and it's just been wonderful. So
I see. Yeah, this year Vienna was the center of machine learning.
Mhm.
I have heard that some people say that we should have all the machine learning conferences in Vienna.
I, yeah, I've heard that too.
Right. Okay. So the first thing that we would like to know is who is Andrew? How did you start? How did you end up here?
So I'll just start by saying I'm one of three workshop chairs, so it's been a great pleasure to work with Natalie Schluter and Becca Rolovs, who put a lot of work into organizing the workshops as well. Unfortunately, they couldn't make it to the conference. In terms of my background, I'm a professor at the Quant Institute at New York University, as well as the Center for Data Science. I lead a machine learning group, which covers foundations of machine learning as well as many different applications. And fundamentally, we're really excited about understanding how to build intelligent systems from a first principles perspective.
Cool. So, I'm sure that you did not end up being a professor, by chance. So, how did you start your journey of where did you study, and how did you end up at at New York, those kind of things.
It's a good question. It wasn't by chance, but it also wasn't really planned. I think people started asking me, what do you want to do with your life when you're in sort of high school? And at one point, I think I said professor, and people liked that answer, and I thought, oh, maybe I'll be a professor. But then once I got to college, I completely forgot about that and became sort of quite worried about what I wanted to do with my life. And there were lots of things that I was interested in. For a long time, I thought I would be a professional musician. I almost didn't go to college, actually, but I thought I might regret not going, so I did. And I really enjoyed physics and math, especially when I was an undergrad, and thought I might do theoretical physics, but the types of theoretical physics I was interested in didn't really have many career opportunities associated with them. I didn't really progress to the point of making applications in those areas, but I think it was at the level of maybe one faculty member being hired every 20 years sort of thing in the world. And so that didn't really seem like a viable option, and so I considered medicine and actually started medical school and decided
Seriously?
not to do it. Yeah. And
So you could have become a real doctor.
exactly, yeah, almost. And I ended up trying to combine my interest in physics with medicine at the end of my undergrad. So there was a particle physicist at a particle accelerator laboratory in Vancouver called Triumph. It's the largest cyclotron in the world, and he was building a new positron emission tomography device built on completely different physical principles, and he needed to redo everything from scratch, imagery construction, etc. And so I started talking with him about this because it seemed like an interesting project. I didn't know at the time that it would involve machine learning, and machine learning wasn't on the radar in the way that it is now. AI even then was symbolic logic. It's not what we consider to be AI now typically. And so I found it to be a really fascinating project. He showed me all these papers from Chris Bishop in the 80s about neural nets. He was a physicist, so at that time in the mid-2000s, actually neural nets were really out of favor, but my physics advisor didn't realize that. And so I actually initially started learning about neural nets and thought these were very exciting approaches to modeling, and they were actually very suitable for the problem I was trying to solve, basically localize the position of a particle that's moving around and emitting light in all directions. It's this sort of task regression problem, essentially, where you really need to carefully model the dependencies between the different spatial coordinates, and so a neural net can do that quite naturally. And I thought, okay, this is a very exciting discipline. It's very quickly moving. It's kind of like applied math. It's very broad. You're not going to get stuck necessarily doing one thing forever if you don't want to be. And so I just kind of went with that, and thought it would be fun to live abroad. So I was in Vancouver at the time on the west coast of Canada, and I applied to 3 places: Toronto, Oxford, and Cambridge, and I was fortunate to get offers from each of them, and Cambridge seemed like the biggest adventure, and so I ended up going there and working initially on Bayesian nonparametrics, and then since then my interests have really expanded.
Cool. Very good. So after Cambridge, you became a professor at NYU. Is that correct, or you did a postdoc?
I did a postdoc at CMU for 2 years. So Cambridge was nice in the sense that it was quite specialized. The group was really focused specifically on Bayesian nonparametric modeling and Bayesian nonparametrics as the answer to building intelligent systems from a first principles perspective. So you get to hear lots of debates about like subjective versus objective Bayesianism, and like parametric versus non-parametric and so on. And so it was nice to see discussions at that level of detail and people being very passionate about it and so on, and really wanting like a philosophy that was driving their approach to model construction. I think elsewhere in the field, sometimes it feels like we're just throwing a bunch of stuff at the wall and seeing what sticks. It was nice to sort of have like a guiding philosophy, even if it wasn't always completely respected. There was, principles that were driving the way that we thought about model construction. At CMU, it was kind of the opposite in the sense that there are loads and loads of people working on a variety of different types of machine learning research. So going into the office there was almost like just going to a conference every day, and you got to see all sorts of new things that you hadn't been exposed to. And so I would say my interest broadened very significantly at that point, and I became quite excited in particular about numerical methods as a foundation for machine learning, numerical linear algebra, and that's a thread that's really continued throughout all of my work even until now. And then I moved to Cornell as a faculty in the operations research department, also as a field member in computer science, statistics, and applied math. And that was a really great experience. It was a relatively small department. I don't know, roughly sort of 15 faculty, and so we all knew each other very well and often attended one another's classes, and there was a lot of support and feedback. And then after a few years, I moved from there to NYU in New York City.
Excellent. So you have seen a lot of different things, right? Some medicine to you had a head start in neural nets, Gaussian processes, and CMU with all sorts of like new ideas. Now it is 2024, right? And what is the most exciting thing here?
There are a lot of really exciting things happening in machine learning research, and at this conference specifically. I think it's probably the most exciting time to be doing machine learning AI research. The field is growing. There's quite a variety of different approaches and perspectives. There's lots of opportunity to try to answer fundamental questions. Like obviously everyone's heard of language models, but not many people really know how they work or why they can generalize in such a surprising array of different settings. And so there's a lot of exciting work being done to understand that. At this conference specifically, I've seen a lot of work on scaling laws, like this idea that as you increase the amount of data available and the size of the model, you can predictably improve performance in a number of different settings. These have been essentially empirical laws, but there's a lot of excitement about theoretically trying to understand why this happens and to characterize scaling laws in different types of settings, like under distribution shifts, etc. And so it's been really exciting to see that kind of work. There are certain application areas that have been identified as challenges, like good video generation that respects physics and things like this. And so at the poster sessions, I've seen a lot of interest in those types of papers, as well as the more kind of philosophical, kind of fundamental papers that are really trying to understand things. And so I think, there's a really a great variety of exciting work that's happening right now. And one of the things I always really appreciated about the machine learning community is that they're relatively open-minded about trying new things and considering different types of ideas, especially if they can be demonstrated to work well empirically.
Right. So I think there is a lot of maybe misunderstanding in the public about machine learning, about AI. Of course, with any type of hype, there is going to be all sorts of like ideas about how these things work. So if there is one thing that you could try to correct about the misunderstanding of what machine learning is, what would that be?
There are so many misunderstandings, and it's really hard to change people's minds. Like once a certain idea has sort of planted itself across a large enough number of people, like it's unclear whether you can ever change their minds. Like there are lots of sort of narratives that I think are now definitively untrue, like the importance of implicit biases of optimizers and generalization, the mysteries around benign overfitting and whether that's actually distinct to neural nets or more general, double descent. I mean, I think many of the phenomena that have been presented as mysterious and distinct to neural nets are actually neither. Like they're fairly understandable at this point, and that sort of behavior has been demonstrated for a variety of different model classes. So I think in that list we could include the successive overparameterization, double descent, benign overfitting, and now we're starting to see even scaling laws aren't specific to neural nets. And so that's not to say that there isn't anything that's different about deep learning. Obviously there is, and it's been very successful empirically, and like the way that they can do representation learning is very interesting, but not completely black box. There's a lot to understand, but we're starting to get a better understanding. So yeah, I think there are a lot of kind of misconceptions about how these models work.
I mean, many years ago, right? Maybe 10, 15 years ago, it was very difficult actually to publish anything that was related to neural net, right? At this conference, right? And it is completely the opposite, right? So, but you're saying that it is not specific to neural nets, many of these phenomena. So, what are other models that you think that all these kind of phenomena that we can observe them, without just relating to neural net.
So if we think about something like benign overfitting, which is the observation that a neural net can fit structured data and generalize well, but also fit noisy data without very much training loss, which suggests with kind of certain types of generalization theory that you wouldn't necessarily expect the good results on the structured data, is something we can reproduce using other model classes. So this was probably most famously demonstrated in a paper called Understanding Deep Learning Requires Rethinking Generalization. And it wasn't like understanding machine learning requires rethinking, it was understanding deep learning. And so the question is, can that behavior be demonstrated using other model classes, and can we understand why it happens? And I think it's just a consequence of having a model that has an expressive hypothesis space, and then also has a simplicity bias, meaning that if it can fit the data in a particular way, then it will. But if it can't fit the data in a nice way, it's still capable of doing that because it has an expressive hypothesis space. So a super simple example of that could be, say, having a large polynomial and then penalizing the higher order coefficients more than the lower order coefficients. And so if we see some structured data, then it will try to fit that data using a very simple sort of lower order polynomial, essentially. It won't put much weight on the higher order terms. If we generate noise, it'll also be able to fit that data, and it will use the higher order terms because it can't really avoid doing that anymore. And so that's an example of a model that it's very simple in some sense, very basic, a polynomial, but it can demonstrate benign overfitting. We can also exactly reproduce the results that were in that paper using Gaussian processes. So Gaussian processes represent a very expressive hypothesis space, but they have biases, strong biases towards certain types of quite simple structured solutions. And so if they can fit the data in a simple way, they will. If they can't, then they also can achieve zero training loss. And so we can sort of see that behavior. I would suppose what's different about deep learning is just the extent of its empirical success. So, for example, if we look at a problem like CFAR, which at this point is becoming a bit of a toy image recognition problem, but was challenging for a number of years, neural nets can get 95% plus accuracy on that problem, whereas like alternative models are getting less than 85%. So that's a pretty big gap, and possibly you could do better by trying to get these other model classes to do representation learning. But often what you would do to achieve better results would start to look more and more like deep learning, like having different layers and kind of discover representations in a similar type of way.
Yeah. So you have talked about an array of interesting trends in machine learning. So what are, okay, not everything is rosy. So what are like the disappointing trends in academia that you might actually see? Like, do you have an example of something that you think that this is not the correct way?
I think there's too much of a focus on getting slightly better numbers on known benchmarks.
Uh-huh.
And so that's probably the easiest way to get a paper accepted. It's like you start with some problem, like there might be like spurious correlations or something like this, or group distributional robustness, and there might be a benchmark like water birds, where you have water birds and land birds, which are respectively typically on water and land, but you might have a land bird on water and so on, and your model is still supposed to correctly classify it as a land bird. This was an interesting motivating problem for a while, and people developed pretty effective approaches to getting good results on that benchmark. And it felt at some point like, okay, well, it's time to move on to different questions, like what happens if we don't have much group label information in the training set, or we care about uncertainty representation, or we want good average case performances as well as good worst group performance, etc. But instead of considering those types of questions, it seemed like the focus was overwhelmingly on like how do we go from 90% to 91% on just the classic waterbirds problem by just tweaking a code base and changing a few things, tuning hyperparameters. And so I mean, it's not like this is like really bad or anything. It's just not necessarily the most exciting kind of work. And I think there's a lot to gain just by considering fundamental variations on the questions that we're asking, and not necessarily benchmark chasing as much. Yeah.
I think there is a saying that for any model, there is a benchmark that it can beat every other model, right?
Yeah.
So there is a benchmark hypothesis.
It's like a sort of a no free lunch theorem.
Yes.
Thing. Yeah.
Very good. So now let's maybe focus more on the workshop that you have been co-chairing. How was the organization? So how many, can you give us some, statistics about how many, submissions you had? How did the process go? How long it took? And, what happened really behind the scene?
It was a lot. So I had two wonderful organizers, Natalie and Becca, who did a lot of amazing work. We had many meetings and discussions about how we wanted to organize the workshops, what the call for proposals would be like, which is really the first step, putting out this call that sort of describes the submission instructions, how the submissions are going to be evaluated, what might be emphasized this year, and there are certain things that stay the same from year to year, and then other things that change. So, for example, this year we had an emphasis on debates and things like this as part of the panel. The panel itself was actually a new thing from last year. So I've been a workshop chair before, and that was something that we introduced in that last series. And this is actually something I broadly also like about the machine learning community. They enjoy experimenting with things and trying new things. And there's like the famous NeurIPS experiment where papers were replicated and sent to multiple area chairs and so on. And so we tried to do something in that spirit with the workshops as well. After putting out the call for proposals, then we get a bunch of submissions and we have to review them, and that also changes from year to year. So I guess in terms of backgrounds, I should say I've as well as been a workshop chair, I've also submitted a lot of workshops in the past. So I've organized about 12 accepted workshops, and obviously I've submitted more than that. And over time, it's been interesting to see how the processes have evolved. So they were relatively informal, I would say, at the beginning. Like you would submit something and it would basically just be a black box, like accept reject decision with no feedback. And then that would sometimes change, where you would get like maybe one line like, okay, another proposal has been submitted on a similar topic, so sadly we can't have your proposal this time, or like maybe if you change this or that and resubmitted it, that could be good. And I think over time we've gotten used to sort of getting more and more feedback about things, and that's what we've tried to do, especially I think in this iteration of the workshops. So we ran it on open review. We got like a huge pool of reviewers. I forget how many, but it was many hundreds. It was like running many conferences in some sense. Like each workshop is like a conference, and so it was really a lot of work, and there were a lot of logistical challenges in getting the workshop proposals reviewed. Also challenges in the distribution shift, I think, between paper reviewing and workshop reviewing. So we set it up on open review, And we had anonymous reviewers providing feedback as well as scores, which mirrors what we see in paper reviewing.
Yeah.
But the process is different than paper reviewing.
Yeah.
And so, for example, the scores generally were a lot higher than what we would see for paper scores. So maybe an average paper score, I don't know what it would be normally, but let's say it's 5 or something like that. It was sort of roughly almost 7 for the workshops, which was nice. I mean, there were a lot of strong workshops, but we have hard physical constraints on how many can be accepted, and there was like, sort of an order of magnitude more submissions than we could accept. And the process is a bit different as well. Like, I didn't single-handedly make any decisions, but about which workshop proposal to accept or reject. But you could be in a situation, for example, where there are like 7 workshops that are submitted on almost exactly the same theme,
Right.
and they all get relatively high scores,
Right.
and you can only really accept 1 or 2 of them in that case. Whereas if they were papers, maybe you could accept all of them. Because you're not necessarily selecting for diversity of topics and things like that.
Correct.
Like you would be with workshops, especially where workshops have a bit of a flavor where they're trying to like introduce people to the subject and things like this, and there might be a reasonable amount of overlap. And so yeah, in the end, we accepted 30 proposals. There were a number of criteria that we outlined in the call for proposals that were kind of important factors in making decisions. I'm happy to talk more about that if you have any questions about it. Yeah.
So on the diversity topic, for instance, you said that there are like 30 workshops, but like 10 of them are on foundation models, right? So how did this how was the decisions about like?
Right.
So it's like heavily, right?
So 30% or so might be on foundation models, but maybe 95% of the submissions are on foundation models. That means there's been a lot of manual correction actually to compensate for that and to try to increase the diversity of topics. And then I guess within foundation models, there are a bunch of different types of questions that people are asking. I mean, broadly speaking, my advice for submitting successful proposals is to choose a topic that's going to resonate with a reasonably large number of people. It can't be too idiosyncratic or specialized, but at the same time, you want like your own take on it or some sort of twist in the question that you're considering, kind of like what I was talking about with research, where you don't want to just ask the same question that everyone else is asking. You want sort of some new perspective that will introduce, some fresh discussion. And maybe, avoid having workshops that are, I mean, this is more of a personal opinion, and other people might have different opinions about this, but like workshops that are like the 10th iteration of some particular workshop on a particular theme. It's like, since there is really a lot of competition and so on, sometimes priority will be given to new time organizers or workshops that are really about something new that hasn't really had a previous version, even though people do try to make some change in emphasis from version to version of a workshop.
Right. As you alluded, like these workshops are like mini conferences now, right? And maybe we'll see, but in previous years, at least some of the workshops they were like completely full and just standing people like in the backs. Have you had any like planning for that this year, or it was like out of your scope?
Yeah, so we put a lot of consideration into which workshops would be assigned to which rooms, and this involved, the topics that they were considering. So there's some topics that are going to be clearly of very broad interest, others that are very exciting, but a little bit more esoteric in some sense. And so we thought about that and the way that the rooms were assigned. We also, in several cases, considered how many submissions had been made to the workshop. So many of these decisions were made before we had that information, but sometimes after we had that information, we made some revisions or sort of figured, okay, actually there were a lot of submissions this workshop, more than maybe we anticipated, and so we'll try to give them a bigger room. And so it was based on that, and sometimes based on requests. So it was, an important consideration. Sometimes there are still surprises, though. Like we organized a workshop at ICLR on differential equations for science, and to me that, of course, is an exciting topic, but it did seem a little bit esoteric and ended up like just, people standing everywhere and like really trying to get in and so on. So sometimes there are these like topics that are new enough, at least within this particular community, that it's hard to gauge how much interest there might be, and sometimes you can be pleasantly surprised.
So I can imagine like with organizing, in particular organizing workshops that are like now, they're in high demand. There are a lot of submissions, and do you have like how many you selected at the end? Like what was the percentage?
It would have been roughly 20%, maybe a bit under
Wow.
that.
Okay.
Yeah, yeah.
So I assume you get a lot of complaints. Okay. So how were they handled? Like, what were the complaints?
Well, people are very passionate about workshop proposals, and so I like that. I like that people care enough to complain sometimes. They put a lot of energy in it. They're very invested in it. I mean, I've been an organizer for all sorts of different components of these conferences over the years, and I would say people are particularly passionate about the workshops, and that was something that I found quite interesting. I I would say maybe there were some people who were surprised that their proposals weren't accepted given the average scores. So that's kind of related to what I mentioned before. Like there is a bit of this distribution shift between paper reviewing and workshop reviewing and decision making around workshop acceptances. And people weren't necessarily prepared for that because it probably felt a bit too much like paper reviewing. And so I would say there weren't a lot of complaints, but there were a couple people who were confused or upset that their proposal hadn't been accepted, given that it appeared to review very well. And in most cases, I think where that happened, it was because there were many workshops that were on a similar theme that were submitted, and maybe priority might be given to new organizers or slightly different sort of perspectives on these topics, although there wasn't really a hard rule about it.
So any interesting complaint?
Beyond that, not really. I don't think
Okay.
so.
So are you involved next year with the organization of the workshop, or?
I don't know. I don't think that's been decided yet for ICML, so
Okay.
possibly, but I'm not sure.
Okay. So for the little boys and girls who want to be one day to be the workshop chairs, what is your suggestion? Like,
Yeah, I guess it's always hard to give advice based on your own experience because you don't know which parts of it actually relate to what's happening now. But I think just organizing workshops is really a good starting point. So I've organized a lot of workshops, and that gives you really a good preparation to be a workshop chair and to understand, what it's like on the other side of this process and what the frustration might be and what you want to avoid and what you might want to change and what you wished had happened when you were running the workshops yourselves or submitting them. So that's probably the main advice I would give. Also get involved just generally in conference organization. So, when I was a PhD student, it wasn't uncommon to just be a volunteer and like help with video recordings or registration desk or whatever it might be. I also was expo chair a long time ago, and for two conferences, and then tutorial chair multiple times, and then I was asked to be workshop chair. So I think if you're just engaged with the organization process at any level, then you become visible as someone who might be, a good choice for helping with this kind of organization.
Okay, very good. Any final comments?
Well, I'm really looking forward to the workshops. So they're on Friday and Saturday, and I hope a lot of people can come. They're one of my favorite parts of the conference. I actually really like how the conference is structured in general, how there's the expo and the tutorials, which really, help people get a foundation to appreciate like the main papers and the poster sessions. And we're right now in the middle of the poster sessions, which is also one of my favorite parts of the conference because you can just see all sorts of work that might not be on your radar. Probably the most common question I get is like, how do you discover papers or like new work? Like, do you use Twitter? Do you use Google Scholar? Do you browse archive? Like, it just seems overwhelming at this point, and it's easy to miss a lot of stuff. And the poster sessions are really just a great opportunity to discover work that you might not be encountering in any of those other settings, and you can just walk around and ask targeted questions. And so that's been great. And other than that, really looking forward to the workshops.
Yeah, and I think one of the things that I really appreciate about the workshop is the fact that these are going to be the next. Some of them or many of them are going to be the next good ideas next year in a conference, right? So these are the seeds of very interesting ideas that you see in the workshops, and people pick up on them, and then they evolve, and you see that that particular paper that you saw in the workshop is now an amazing paper in a conference, right? So that gives like a very interesting perspective, and that is what I really like about the workshops.
That's a really good point. So the workshops tend to be a bit less formal than the main conference, and are a bit more focused on brainstorming. So the submissions might not be sort of full-fledged projects at that point. There could just be sparks of ideas, and people are looking for feedback. And I really, really love that dynamic because often people are very honest in the way that they're talking about the work. Like they're quite happy to expose, any deficiencies and really try to sort of brainstorm to develop the project further. Also, in some sense, they're a bit like machine learning conferences used to be like 15 years ago. Like, I mean, the main conference is just growing so much. It's good in a sense because there's such a variety of topics and all sorts of different people you can connect with. But I think the workshops often give you sort of a different sort of focused perspective on a particular topic, and there's a community of people associated with that topic that you can engage with in a relatively informal way. And so they are like mini conferences, but each workshop might be almost like ICML or NeurIPS was like 15 years ago.
Yes.
And so, it's a different dynamic, and it's something I really like too.
Very good. Okay, with that, let's finish this very fun conversation. Thank you very much for being here, for sharing your views and all the things that are happening. Thanks for organizing. I think it takes a tremendous amount of efforts to do that, and the other organizers who could have not been here. Very good. It was amazing.
Thanks so much for hosting, and thanks for all your work as the communications chair.
Yeah. Thank you.
Thank you. See you later.